A Newton's law problem, also involving the force of friction. A 1500 Newton force is applied on a 200 kilogram crate to move it across the floor. If the coefficient of friction is 0.250, what is the crate's acceleration? So we're given lots of information here. First, we're given that we have a 1500 Newton force that is applied. So we're looking at force applied equals 1500 newtons. We're also given a mass of 200 kilograms. So mass equals 200 kilograms. And we know that this force is applied to a crate to move it across the floor. We know that the coefficient of friction, mu, equals 0.250. So we're looking at mu kinetic because the crate is moving. And we know that the crate's motion is changing because we want to know or find out the acceleration. There's no mention of constant speed. So we have this idea here of what is the crate's acceleration. So that's what we're looking for. So A equals question mark. All right, so we're talking about a Newton's second law here. If I'm looking at a force diagram, I have a floor. And I have a crate. Sitting on that floor. And I have some forces acting on that crate. So I have a dot in the middle, and I have a force applied. So I have this force here. And I know that that equals 1500 newtons. I have this coefficient of sliding friction, and I know that this vector going here in this direction for friction has to be smaller than my applied force because we have some acceleration. So I have a smaller frictional force here that I'm going to draw. So frictional force kinetic, which I don't know, but I do have a way to find it, just like in the previous problem. I also have this idea of weight acting downwards. And we know that weight is mass times the acceleration due to gravity. And I have this idea of the normal force acting in the upward direction, holding the crate from accelerating towards the center of the Earth. So I have several forces here, and I want to find the crate's acceleration. So from the equations that we've been working with, we know that our net force equals mass times acceleration. We also know that our net force in the horizontal direction is the result of adding the force applied and the force of kinetic friction. We know that the force of kinetic friction equals mu times the normal force. So if we work our way backwards, A is what we want to find. We want to find acceleration. So if we want to find acceleration, we're given mass, but we don't know the net force. if we work here, so we need to find the net force in order to find acceleration. So we know we have net force here, and we know that net force is the force of kinetic friction plus the applied force. Well, we're given the applied force, so we know that this is 1500 newtons. Still need to find net force, but now we have a problem because we don't know the kinetic force of friction. But we do know that kinetic force of friction is mu times the normal force, and we're given all the information that we need to find this. So mu times the normal force is going to equal our force of friction, which we're going to put back here in this equation to find the net force, which we're then going to put here and solve for the acceleration. So let's go ahead and do that. So our friction force of kinetic friction equals mu times mass times gravity. Remember, our normal forces equal and opposite weight, so we're not worried about our negative sign here. Equals 0.250 multiplied by 200 kilograms multiplied by our acceleration due to gravity, assuming we're on Earth. So our force of kinetic friction ends up being .500 newtons. So now our force of kinetic friction can go up here in this equation. So our net force equals 500 newtons. And remember, our force of friction is always acting opposite the direction of motion. So we're going to put a negative sign in there to indicate our direction, plus our applied force, which is 1500 newtons. So doing the math here, our net force equals 1000 newtons. Now I'm going to take this number and put it back up here for net force. So our net force equals 1000 newtons equals mass, which we said was 200 kilograms. Multiplied by A, which is what we're looking for. So if we divide this, and we divide this, our acceleration equals .0 meters per second squared.